Welcome back to Kanjilal Clean Enviro. Today we are going to take over from where we left on our last video. Okay. So on our last video we explained in detail fabric filters, fabric dust bag and pleated dust filter. This pleated dust filter are basically cartridges, filter cartridges. They basically stand on their own, but this fabric filter, they are just fabric. So this fabric are collapsible, just like clothes. So in order to hold them, you need dust bag cage. There are cages where there are horizontal metallic rods and then vertical rings and horizontal rods. These are either made up of stainless steel or galvanized iron. Generally, we make this from galvanized iron because this is cheaper. This is less expensive. And also, we sometimes provide AOL coating to this galvanized iron in order to make it last longer, and so that the dust chemical cannot react with the cage and damage the cage. Okay. So these cages, they somewhat look like this. You have a plate at the bottom, metallic plate, and then have vertical rods and horizontal rings, metallic rings. Okay. While manufacturing this, you must ensure that the finishing, the cage has a smooth finish. Okay, so that there is no edges. Smooth finishing means no edges coming out of the cage. Otherwise, it will tear the bag apart. Okay. But these pleated ones, they don't need no cage needed. Okay, no cage needed, because these pleated bags, they are themselves, these pleated bags, they are themselves placed inside a core, a polypropylene core or a steel core. Okay, and pleated dust bags are more efficient. They require less cleaning because they clean faster. Okay. Now, while implementing this technology, we take into account various parameters like the inlet gas velocity, inlet gas velocity, outlet gas velocity, can velocity. So can velocity is basically when the air is moving inside. These are dust bags. When the moving inside, then the velocity at which the air is getting pushed in between two bags is the can velocity. Okay. Then another velocity yet we take into account is the velocity with which the filtered air is rising upward from the bottom of the bag after getting filtered. Okay. So this filtered gas velocity, these things we take into account while implementing this kind of engineering. All are measured in meter per second. Okay. There's a lot of details about what is how do we measure can velocity, and there's also another parameter called uh, cloth to air parameter, cloth to air cloth ratio. So in a nutshell, we use this kind of parameters to implement this kind of engineering, right? So I think we have discussed enough to wind up with this air pollution control. Okay. We have discussed enough of this. And now we will start off fresh with water pollution control. Okay, we're finally done with the air section. Now this water pollution control, as I told you, it consists of biological wastewater treatment, and then membrane and media and fabric filtration, right? And finally we also have the ESP or ionizer or deionizer technology. Okay, when it comes to water, first we have to convert the wastewater into reusable water. What is the first step? First step of water pollution control. First step is wastewater treatment. That means conversion of waste water into let's put it this way, treated water. If we avoid this step, then we cannot. It's very difficult to achieve the final treatment of water, because if we directly push wastewater into membrane, then it will get choked. Okay, so this is not the way. This is not the way. Okay, so first and foremost, if we have bad quality water, wastewater, we have to treat this with biological solution. Okay, using and here what we use beneficial bacteria. Okay, because even if we filter the unwanted waste, then where do the unwanted waste go? If they go into the sewer, okay, if unwanted waste from water goes into sewer, it will block the sewer. And then again, when it is going to the sea, all the filtered sediment, if it's going to the sea or river, then it will cause pollution of water bodies, right? So wastewater treatment process is a bit different process. It is a bit more more unusual process as compared to the air. Okay. So, in order to understand this, what we have to understand first and foremost is what is beneficial bacteria. What is the significance of bacteria? Okay, what is the significance of bacteria? A bacteria, you know, the actual ruler of the world is bacteria. All around us in the atmosphere, in the in all the layers of atmosphere, there are bacteria. In your body, inside my body, inside every human species body, inside every animal species body, you know, there is bacteria. Even inside plant, okay, they also have bacteria in their root. This is called the beneficial bacteria, okay. So also there are pathogenic bacteria. So let's classify the bacteria the way they are. Bacteria are of two types. One is beneficial bacteria, one is pathogenic bacteria. Pathogenic bacteria is the disease causing bacteria. When you have fever, when you have a stomach problem, okay, when you have diarrhea, then pathogenic bacteria comes into play. Then in order to cure these problems, you eat antibiotic. Antibiotic is beneficial bacteria. Antibiotic. Now this beneficial bacteria, along with antibiotic, when you are eating this, when the human body is eating this, the antibiotic enters the stomach, and then it eats up all the food. It eats up all the food that is supposed to be eaten by pathogenic bacteria. Okay? So when the beneficial bacteria eats up all the food in your stomach, then the pathogenic bacteria gets deprived of food. Then the pathogenic bacteria, they die. Okay? The pathogenic bacteria that was bad for your body, they will die because the beneficial bacteria has entered and it has led to the death of pathogenic bacteria by virtue of competitive nutrition. Okay, this is called competitive nutrition. The same the same concept we use in wastewater treatment, right? Look, inside a human body, in your saliva, there is beneficial bacteria. Okay, let me divide. In a saliva, there is beneficial bacteria. In your stomach, digestive juice, there is this beneficial bacteria. Okay, so if there were no beneficial bacteria, then we die. Okay, we die. We cannot survive without beneficial bacteria. So beneficial bacteria, inside your saliva, inside the stomach digestive juice, it is needed to make you alive. Okay, so this is good for your body. This is better than the medicine. Beneficial bacteria is better than the medicine, to survive. So you should not ask stupid questions like, if we use bacteria in wastewater treatment plant, then that is contaminated water. No. If there is pathogenic bacteria inside wastewater, then that is contaminated water. Beneficial bacteria is needed for the planet to survive. Right? I hope I made this thing clear, because many laymen, they ask saying such kind of question in this industry. If you have bacteria, if you are giving bacteria in the wastewater, then that bacteria is going to kill us. It's a misfortune that we get to see such kind of stupid people and working at very, very big companies in the EHS department, safety department. It's very pathetic to come across such kind of animals in the industry. So that's why I started from the very basic, so that you people can easily overcome such kind of stupid people working in the industry. Okay. Now, waste water treatment. So what you need in the water that is coming out of municipality, of your toilet, of your kitchen, okay, and then the water is coming out of factories, untreated water, okay. What do they contain? They contain certain kind of waste, which the bacteria has to, the beneficial bacteria has to consume. The bacteria release enzyme, and then this enzyme convert this waste inside water into pure water and carbon dioxide, and then the beneficial bacteria, they breed amongst themselves, okay. They give birth to offsprings, so it gives rise to new beneficial bacteria or new biomass. This is also called biomass, right? If you have the right formula, okay, if you have the right formula of beneficial bacteria, then this waste will get converted into water and carbon dioxide, and plus there will be clarification of water. The color will be gone because the color was produced by the waste, so water will become colorless. So this leads to clarification of water, okay. This also leads to lesser waste settlement, which is called the sludge. In technical term, it is called the sludge, dead sludge. Lesser waste settlement, lesser dead sludge settlement, because the dead sludge is also consumed by the bacteria. The dead sludge is also consumed by the right formula. If you have the right formula, then it is consumed, and again this is converted into water, carbon dioxide, okay, plus new biomass, as I told you. Okay. In order to achieve this, you have to have the right formula. Right formula. What is the basic of right formula? Right formula of beneficial bacteria. Beneficial bacteria is also called biomass. Okay. Right formula of biomass should have multi-strain bacteria. Okay. This should have multi-strain bacteria, okay. Plus it should have nutrients. Now I'll tell you why you need multi-strain bacteria, why you need nutrients. Say for example, this is the waste. This is the, say for example, this is the graph, and at the bottom you have final treated waste. Final treated wastewater. What you are supposed to have here? You are supposed to have your water and carbon dioxide, right? Yes, of course, a new biomass. In the final treated wastewater, you have to have water and carbon dioxide. Now, this is the stage of waste, and let's call these stages of waste. If there is a single strain of bacteria, say for example strain number A strain bacteria, say for example this strain is called A, then this A strain bacteria will eat the waste, consume the waste, and convert this into another type of waste. Let's call it waste A, waste type A, waste type A. Okay. Now, for the strain A bacteria, this waste type A is not the food. So what will happen? The waste will be left over in this category, in this type, and it will be left like that. So no complete degradation will be achievable. You know what we and the complete degradation final product we want H2 and CO2. This won't happen. So what we need here, we need another strain of bacteria. So let's call this B strain bacteria. Okay, B strain B. Now for strain B, this waste type A is the food, and it will consume this food and then convert this into, let's call it waste type B. Okay. Now I have just two strains, so it has converted the waste into waste type B. Yeah, which is bit more closer to the final product. You know, more closer to the final product. Better than the waste type A, but it's still waste. Now what will happen? We cannot leave it to this waste type B. Now here we need another kind of strain, bacteria strain. Let's call this C type strain bacteria. Okay, C type strain bacteria. Let's call it. Now it will consume this waste type B and again convert this into waste type C. Okay. Now again it has become, it has got much closer to H2 plus CO2, but still it is not H2 and CO2. So here again we need, say for example, D strain bacteria. Okay, these are different types of strains, types of bacteria strain. Okay. So, like this, we need many strains of bacteria which will ultimately convert this waste into water and carbon dioxide. Okay. So, like this, we need many strains of bacteria. Just two different, 3 different, 5 different, 10 different strains is not going to do. So, scientific research has been conducted to prove that you need at least 50 to 100 different bacteria strains. Okay, the way you have here A type strain, B type strain, C type strain, D type strain, here you need 50 to 100 different type of bacteria strain to convert waste into water plus carbon dioxide, depending on what kind of waste you are having, what kind of contaminations you are having in the wastewater. It is coming out from which kind of factory, it is coming out of which kind of factory, you know, what is the factory manufacturing, what kind of waste they have, you know, or what kind of how many toilets you have in a particular complex, or if you are using more acid or more detergent in cleaning the toilet or cleaning the kitchen. Okay, so whenever you are using the kitchen, you are using the toilet, you are cleaning the toilet, cleaning the kitchen, and now the detergent and soap, everything is going down the sewer and eventually into the sewer treatment plant. So from that you need to ascertain how many strains of bacteria you need. But generally 50 to 100 different strains can convert this wastewater into pure, somewhat pure water and carbon dioxide and new biomass or new beneficial bacteria, because the bacteria are constantly breeding and giving rise to offsprings. Okay. Now, why do we need nutrients? Why do we need nutrients? We need nutrient in order to, the waste in water is already a nutrient. Okay, Now, but for example, bacteria is also like human beings. So, what we human beings eat: rice, bread, meat, veggies. This is our regular routine, regular food. Plus, if we also eat Horlicks, Bornvita, food supplement, okay, food supplement, okay, plus vitamin, mineral tablet. Yeah, people that do gym. If you are doing gym, you drink some kind of protein shake, okay, protein shake. What they are supposed to do? What are they supposed to do? They are basically supposed to boost up your energy. Boost up your energy. And also when you are breathing, you eat some kind of capsule, you eat some kind of tablets to have better breathing with your partner, okay? To have better sex with your partner. So similarly, the bacteria, if we give certain food supplement to the bacteria, food supplement to the bacteria, then the bacteria gets much more energy, and also its reproduction capacity gets increased. So immediately it will start multiplying. Like the baby has taken birth, you gave birth to the baby, to many number of babies at a time, and then as soon as the baby is born, it starts running. Okay, just an analogy. So the bacteria immediately it will start breeding, and immediately all the bacteria will be immediately activated. Okay. Now what about activation? What about bacteria activation? I'll tell you. Bacteria activation. So, as we all know, there is a graph of bacterial activation. Bacterial activation graph. In the x-axis, we have time. Okay. In the y-axis, you have bacterial activity. Okay. Normally, what happens is when the bacteria is born, it has a lag phase. Okay, it is not getting activated. It is hardly getting activated, and this is called the lag phase. After that, after crossing the lag phase, you have the exponential phase, where the bacteria is increasing somewhat exponentially. This is called the exponential phase of bacteria, and then the bacteria activity becomes steady. Okay, steady. So this is the peak activation of bacteria. Okay, this is the peak activation of bacteria, and then again the bacteria will die. Okay, it will die like this. Now, when we are provided, this is a normal graph. This is the normal graph. Now, when we introduce certain special kind of natural nutrients like vitamins, okay, minerals, carbon, nitrogen, phosphorus, okay. That's such kind of a formula we have in our company. Then the bacteria, it will avoid the lag phase, so it will almost immediately get activated. Like, immediately it will get activation. You'll see the activation period, and then the bacteria will be active for a longer period of time. Also, the lifespan of the bacteria will increase. Okay. almost immediately you see the with our kind of bacteria. We are called this congenial bacteria. Okay, our bacteria formula is called congenial bacteria. Congenial bacteria. It was tested at University of Bangor, okay, in the United Kingdom, and since then we have proven the performance of bacteria and we have been using it. So almost immediately you see the activation at no time. Immediately the water will also get clarified and the bacteria will start breeding, and within a matter of few of 1 to 2 hours, you will see the BOD, the COD, everything is getting reduced. TSS, color, everything is getting reduced. And within a matter of like 2 days, you'll see up to around 500 units of BOD reduction. Within 7 to 10 days, you will see the water is treated water, is highly treated water. Within just 7 to 10 days. Okay. Also, if you have fat, oil, grease from commercial kitchen, okay, from commercial kitchen, if you have fat, oil, grease, which is called fog, right? The fog is the hydrocarbon chain, okay, the hydrocarbon chain in the waste or the fog is broken down by the bacteria and converted into water and carbon dioxide, okay, and then this fat, oil, grease will not get accumulated in the sewer. This fat, oil, grease, when it gets accumulated in the sewer in pipe of commercial kitchen, then you see flooding. Then there is flooding. Places where there are many commercial kitchen, hotel, restaurant industry, those places are all the time flood whenever there is raining, because during rainy season this fog gets accumulated into the municipal sewer, and then this blocks the sewer. Causing flood. Okay, so if you use our bacteria in your wastewater treatment plant, or in the if you dose them in the drain of all the commercial kitchen, then all the fat, oil, grease that is there in the pipeline, in the sewer, they all will get melted and converted into water and carbon dioxide within a matter of few hours time. Just a few hours, 1 to 2 hours time, all will be melted. All the fog will be softened. Okay, all the fog will be softened, and they will turn into water eventually. Eventually they will turn into water and flow into the sea or river or water bodies. Okay, so this is what exactly happens. So in a nutshell, this is what our company made bacteria can perform for you. We have special blending techniques. We have special kind of naturally occurring bacteria. Those naturally occurring bacteria, we divide them, we want to multiply them in our labs, and before multiplying, we train the bacteria strains very hard to tackle more and more waste. Okay, so this congenial bacteria, the activity of the congenial bacteria is 6 into 10 to the power 9 CFU per gram, all the way up to 10 to the power 10 CFU per gram. This is so high. Now why? Why? Because it has got 120 plus bacteria strains. I told you bacteria strains, plus 20 plus different kind of nutrients. Okay, biobalancing nutrients, and also many other proprietary products, many other proprietary ingredients. Proprietary ingredients. Okay, so our bacteria can be used in STP, STP, ETP. Okay, congenial bacteria. Congenial bacteria can be used in STP, ETP. Uh, ETP as in factory wastewater treatment plant. Okay, factory wastewater treatment plant, and also it can be used in uh, commercial kitchen drains, commercial kitchen drain. This can be used. If you use this in commercial kitchen drain, then also they won't have to change the pipe. Where they are making pizza, they are making plenty of non-vegetarian food, uh, fried chicken, burger, particularly burger, pizza, fried chicken, and steak houses. You know, they have to clean and change the pipe, clean and change the drain pipe, kitchen drain pipe, kitchen drain pipe, and it is expensive. Very quite expensive to clean and change the drain pipe. If you use our bacteria, then you never have to clean or change the kitchen drain, and also the grease trap. The grease trap also you don't have to change or clean manually, right? If you clean them manually, manual cleaning, then you have to use water jet. Okay, manual cleaning is done by water jet, and water jet is so forceful that it breaks the material of the pipe and grease trap. Okay, so you don't have to use water jets. The drain pipe and the grease trap will be back to their original efficiency, the way they were when you purchased them for the first time. Okay, so our bacteria that we have, that have been used in every kind of factory wastewater treatment, like milk factory wastewater, food wastewater, beverage wastewater, steel industry wastewater, uh, carbonated beverages wastewater, where you have color showing up, and the color is nothing but, most of the time, they're aromatic hydrocarbon chain. And as I've told you, that hydrocarbon chains are broken down by our bacteria and converted into water and carbon dioxide. Okay, so that's the way you also get rid of color. Also in your tannery wastewater, there is fat oil grease, and also there is dye color. So all of that, you can get rid of all of that if you use our bacteria, and their action is almost instantaneous. The moment you use our product, you get the result. Okay. Now, I think I made your conception clear about our about bacteria products in general and the bacteria product that we have. Okay, and also our beneficial bacteria, as I told you, it kills all the pathogenic bacteria by eating up all the food of the pathogenic bacteria. And the same way, our multi-strand bacteria, it also cleans the lake, the pond. Okay, but where the unwanted plants that you that uh, gets developed over the surface of water bodies, you know, what our bacteria eats up all the food, and by virtue of all the food that was supposed to be eaten by the unwanted plants in lakes and ponds, and then the water hyacinth and all, and then those unwanted plants, they cannot grow anymore in the lakes and pond. Okay, they are deprived of their food and they die out. And it also clarifies the water of the lake and pond, and also degrades all the waste into reusable uh, reusable fertilizer. So our bacteria also converts the waste into natural fertilizer. This is also a very vital point. Waste to natural fertilizer. Okay. So instead of dumping the fertilizer, you can reuse this fertilizer. Okay, that has been generated if you treat your wastewater with our bacteria. Right. Uh, Also, our bacteria can be used in composting. If you use this in composting, the action is very fast, extremely fast, and there is no odor. No odor. All odor in the wastewater will be killed by our bacteria, because, for example, say for example, odor is getting caused by H2S, ammonia. So our bacteria, breaks the H2S and convert this into elemental sulfur. Our bacteria breaks this NH3 and convert this into nitrogen and hydrogen gases. Okay, so as because you don't the H2S and NH3 they don't exist, so you don't get the smell. There is no smell. Right? Also, our product can be used in organic farming. Organic farming. Okay, our bacteria is also best for organic farming. Also, the nutrient that we have, this nutrient separately we also sell for seaweed, organic farming. Okay. So this is the basic. Now, as I have told you that the first part of water pollution control is biological wastewater. We have completed this. Okay. Now we will come to membrane and media fabric filtration. And I also already told you the basics, that these are made up of polypropylene or polyester. These are either melt blown. I told you what melt blown is. Polypropylene granules that are byproduct of petroleum industry. They are melted by heat and then blown with air blower in the form of fabric, and they are deposited over rotating mandrel, and they build up in layers, and then we have melt blown, and also polypropylene yarn thread. They are wounded over rotating mandrel. That is called the wounded cartridge. Now they have a cartridge inside made up of either polypropylene or steel. Melt blown don't need any cartridge. No cartridge. No core. No core cartridge. No core is required. They stand on their own, but they need a polypropylene steel core to wound the fiber. Okay. So wounded melt blown is somewhat lesser efficient than wounded. Wounded is more efficient. Okay, this melt blown also can be of 2 to 3 layers. Generally 2 to 3 layers. Some industries want many more layers. So 2 to 3 layers means they have varying porosity. In the first innermost layer, say for example, you have 5 micron. In the second layer, you have more than 5 micron, and in the third layer you have more than what you have in the second layer. bigger porosity, bigger porosity. Why you have this such kind of arrangement? We have such kind of arrangement so that in order to delay the choking. If you straight away use the 5 micron porosity, then uh, the uh, immediately the cartridge will get choked. Okay, so if you have 3 layers, then the bigger particles will be blocked by the third layer. Then the second layer will be blocking the smaller particle, and then the smallest particle will be blocked by the first layer. You know, like this we have different layers. Okay, and the water will come from here, water, and then the water will get filtered by these 3 layers, and then the clean water will pass from the core. Okay, at the middle of the middle axis of the filter. So this cartridge is basically placed in housing, polypropylene housing or steel housing we have, they fit into the bottom, and then here it is connected to a pipe kind of opening, and the water, clean water gets to flow inside this piping, and then these are connected outside, and it's connected towards the periphery, and eventually they are connected towards the periphery, and the clean water comes out of the housing. Okay, so these filters, these cartridges are placed inside such kind of housings. Okay, it's very simple concept. There is no rocket science to it. And after this is called the pre-filtration, and after this pre-filtration you have the membrane filtration. Okay? membrane filtration. In membrane filtration, what you need is, you need to pass the water under high pressure. Okay, in membrane filtration, you need to pass the water under high pressure. Otherwise, the membrane pores are so small, the water will not move. And then you have the final filtration. And after the final filtration, some people also prefer to have another stage of this fabric filtration, if you want to have drinking water. Okay. So the way we have here basically is like this. Now, depending upon industry, the stages of filtration might vary, but I am discussing with you what most of the industries ask for implementing in their system. So generally you have the sand and carbon filter. Generally, I am telling you, sand and carbon filter. After that you have this fabric filtration. Okay, fabric filtration. And then you have fabric filtration, FF. Okay, short form I'm using. After that you have membrane filtration. Here high pressure is needed. High pressure, very high pressure. Here also you need pressure, but here you need very high pressure. But without this, if you use just a membrane, then it would choke immediately. Immediately it would choke. Okay. So that's why you use fabric filter prior to membrane filter. But still, in spite of all of this, you have 60 to 75% water rejected. Reject water. Okay. Of course, you can refeed this reject water here or here, wherever you want. Okay. And sometimes people want another stage of fabric filtration after the membrane filtration. right? Now, as you can see here, a lot of water is wasted actually. A lot of water is wasted. That is the problem. And cleaning these membrane filters is a huge expense. Changing these membrane filters is a huge expense. And also you need to change this fabric filter. This, you remember, this is called melt. Either way you are using melt blown or wounded filter, wounded cartridge, melt blown or wounded cartridge. You also need to change them periodically when they get used up. Otherwise they will break. Okay. So in order to overcome this, a new technology has come up which is called the ESP or ionization deionization technology. Okay. Ionization or deionization technology. Okay. Mainly to get rid of the reject water, because water wastage is something that we cannot afford at this point of time. India cannot afford, America cannot afford, no country in the world, this planet cannot afford wastage of water. That's why this membrane filtration and fabric filtration is on the verge of extinction, and they are looking for some better technology. So that has led to the research in ESP or deionization technology. Okay. In my first video I told you that they have two plates or electrodes where we have positive and negative charges given. Positive and negative charges given. Okay, and then the water H2O will come in between the plates, and the negative charged particles will be attracted by positive plate, and the positively charged contaminants that is there in the water will be attracted by the negatively charged plates. And after that, they will be given, the positive charge will be replaced by a negative charge, and then the negative charge will be replaced by a positive charge, and then this accumulated, positive charge here or accumulated negative charge here, they will get repelled and flushed out. Okay, they will repelled and flush out. Flush. Okay. So after the flushing or cleaning is over, then again we are back to your positive here. As it was earlier, we had positive charge, and here we had the negative charge. Okay, again these plates are back to the original form, and again they will be attracting the positive charge plate will be attracting negative charged particles, and the negative plate will be attracting the positively charged contaminants, and again the cleaning of water will resume, and in this way we will have clean water here, clean water. So here the reject water out of this, is the flush water and the reject water, which is comparatively lesser. This flush water, this is the only reject water. This is comparatively much lesser. Okay, much lesser, much lesser water wastage. Okay, much lesser water wastage. So this is the reason various companies, including ours, we are coming up with deionization technology of wastewater, and also the membrane, they pull out all the vitamins and minerals which is bad for your body, but this kind of technology, it will not suck out all the vitamin and nutrient from the clean water, so the clean water will be healthier. It's comparatively healthier water to drink. Okay, and also you don't have to do much changing. There's not there hardly any membrane, no membrane to change and stuff. You just have to clean and refurbish these plates, which is way lesser expensive as compared to the RO. And also electricity consumption in case of water, is actually lesser when you apply this technology to water filtration. So I've discussed uh, almost everything that is going on in today's world in the field of air and water pollution control, starting right from the basics, right from uh, what our planet, the scientists belonging to our planet, started off, what technology they started off from the scratch when they first started delving into this environment engineering field, you know. Uh, Apart from that, yeah, I've not discussed. You have carbon filters. Carbon filters. Also, you have carbon filters for both air and water. This is very very basic, you know. Carbon filter, and when it comes to carbon filter, then coconut coconut uh, carbon is the best. Coconut carbon is the best option. This using this carbon filter, we can get rid of both odor and color. Okay, and flood control, yes. So if you use flood control, if you use our bacteria multi if you use our multi-strain bacteria in commercial kitchen drain regularly, then this will melt all the fat oil grease fog. This will melt all the fog, and this fog is actually what is responsible for flooding. Most of the flooding is caused due to fog coming out from commercial kitchen drain. So these fogs will melt if you use our multi-strain bacteria with nutrients. You know, it will, if you use a multi-strain bacteria with nutrients, immediately it will start melting all the fog. It will go right till the municipal sewer, and this is a very good way of this is the most effective way of flood control. Then floods won't happen, because whenever there is rain, then the sewer pipeline will will keep flowing all the rainwater into the water bodies. There will be no blockage of water. Okay. So this is the way to get rid of all the water and air air pollution, you know. And we need to plant more and more trees. Obviously. And whenever there is emission, you have to use scrubber, water scrubber, or bag filters, you know, pleated filters, the pleated cartridges inside dust collection system, placed inside dust collection system. Okay, this is the way to go. And the best way of water pollution control is biological wastewater treatment, followed by either membrane and media filtration, or ESP, or deionization technology. And when talking about fog, always remember that fog is so dangerous that only 2% of fog leads to reducing the hydraulic capacity of sewer by 20%. Okay, This fog is so much dangerous. We neglect the fog. We neglect the fog because we don't know that 2% of fog can reduce the hydraulic capacity or hydraulic efficiency of the sewer by 20%. So imagine so many restaurants, so many commercial kitchens, so many hotels, so many eateries at a particular locality, and they don't have any fog management treatment whatsoever. I strongly recommend the Indian government to put fog management practice in place. This is called fog management. Fog management practice in place for all commercial kitchen. For all commercial kitchen. Okay, and our bacteria, when you use, then it reduces the fog to less than 5 milligram per liter. Okay, when you use our product, multi-strain bacteria with nutrient, so many strains of bacteria we have along with nutrient, it reduces the fog to less than 5 milligram per liter of wastewater, of drain wastewater. It is that much powerful. And many developing countries like Australia, UK, Ireland, all of their governments have put fog management practice, fog management compulsory for all commercial kitchen. Compulsory. In these countries, it is compulsory to use such product, bacteria product, in their drain, in the kitchen drain, to melt the fog, which is called fog management. It is compulsory for them to do fog management. The same is advised for Indian government, Mananiya Modi ji, and all the Mananiya chief ministers in this country, to make it mandatory for all commercial kitchen, all restaurants, eateries, hotels to do fog management. Otherwise, they should be fined. Okay, because in these developed countries, Australia, UK, Ireland, and many other European countries, also, I think USA, because USA buys our product. Okay, USA, they have fog management in place. Otherwise, they have to face fine. Okay, otherwise they should be fined. All restaurant, all hotel industries, all eateries should be fined if they don't treat the fog. Because thousands of people are dying every year in Mumbai, in Haryana, in outskirts of Delhi, Madhya Pradesh, and many other places, because of flood. When it is raining, there's huge flood, and so much of economy is getting damaged, so much of business is getting damaged. And all of this is happening because there is no fog management in India. Okay, so that's all. I'm concluding the second part of my environmental engineering course. Thank you so much for watching my videos. Please like, subscribe my channel, and also comment, and let me know what if there is any particular topic on which we should make video for you, or what kind of technology you are looking out to solve your environment problems. Okay, thank you so much. Have a good day. Bye bye.